I don't think any of these presenters ever talk about the fact that you're so nervous when you get up here, even if you've done it like 1,000 times. It's like really nervous to be here. So, hi, I'm Josh Schneider. If y'all remember me, I presented here last year. This is my second year here. I am a test automation architect at Dell Technologies. Standard disclaimer, I'm not speaking for the company or anything here. This is all my own thoughts, although I think they think the stuff I'm talking about is pretty cool. I'm going to talk about decorators, because I love decorators. This is one of my favorite parts of Python, and so I'm happy to get to share it with you guys a little bit. I'm going to start out by kind of explaining what a decorator is, and we're going to like a level set. And then I'm going to show you some actual examples. We're going to actually run some code in this session and kind of get to play around with some things. So first off, that's me. Those are the two child processes I spawned. I'm trying to keep them from terminating. And if you were at the speaker get-together the other night, I will try not to knock over anything tonight. All right, so let's start by talking about a decorator. What is a decorator? A decorator, in its simplest terms, is a function that takes a function and returns another function in its place. And somewhere in that explanation, there is a white van going over a bridge in slow motion. If you've seen the movie Inception, you get that joke. If you don't, sorry. We're going to talk actually about two different ways of talking about decorators. First, we're going to talk about decorators itself, and then we're going to talk about the decorator syntax. But like I said, that definition, it's a function that takes a function and returns a function in its place. And this works because in Python, functions are first-class objects, right? A function is an object just like an integer or a string or a list or a set or a tuple or a dictionary or my really cool class. It can be passed as input to a function. It can be returned as output for a function. And a decorator uses this. What a decorator allows you to do is kind of wrap code in other code. And there's a couple of different benefits and stuff that you can get out of that. The anatomy of a decorator here, you can see just a really, really basic dumb example that I have. It's a decorator that takes a function. Notice this doesn't actually do anything. I can. I got a request to zoom in. And here, I'll even make the window bigger, just so y'all can read all of this. You're welcome. This decorator doesn't really do anything. It wraps the code in nothing. But you see where those ... comments are? Hey, this space reserved for your code. It means you can do things like intercept inputs to the wrapped function. You can intercept outputs. You can take action before or after the wrapped function call. You can do all kinds of really fun things in here, and I'm going to show you a few examples. But this is, in the simplest terms, what a decorator looks like. And yeah, we can go deeper. Like a dream within a dream within a dream within a dream within a dream. Yeah. So let's talk about the decorator syntax. That's this little @ sign in front of a function name. That is, when we talk about the decorator syntax, that is the way that we can use a decorator. That @ symbol in that function name means whatever comes next, whether it's a class or a function definition, this decorator is going to be passed that thing. It's an easy way of saying, hey, I belong to this thing, right? Adding this little @ silence exceptions is the same as doing this line of code. So you are calling silence exceptions and passing it my activity. By the way, silence exceptions would probably not be a great decorator, and we'll talk about why in a little while. There are a bunch of decorators in the standard library. You've probably played with a couple of these before. Anybody here done a class and done an @ property to do a property? I'm sure everybody's dealt with that. There are some other really cool ones, like the context manager decorator, which takes any function with a single yield statement and turns it into a context manager. There are some other really neat ones. The data classes wrapper is one of my favorites. That is awesome, saves you so much boilerplate writing. And then there's some conventions. I'm going to use this document. I will let you guys read that later. All of this information is on GitHub. Andy, you talked about GitHub Actions. There's actually a GitHub Actions workflow on this repo that automatically generates the static site content, puts it in a zip, and releases it every time I push a change into main. Okay, so let's start talking about types of decorators that we can play with. The first is a class that I like to call observer decorators. These are decorators that observe and report behavior, but don't try to change the behavior, right? This allows you to sort of insert code before or after something. This is really useful for things like debugging or performance measuring and things like that. I'm going to use an example here what I call the logging decorator. This is just a really simple decorator to log to a Python standard logger, hey, this function got called. Here are the inputs it was called with. And hey, this function finished. Or, ooh, this function got an exception. Let's log that information there. So I'm actually going to switch to, and is this readable or do I need to make this way bigger? Bigger, they all say, bigger. Everything's bigger in Texas, and we made the code bigger. I promise, though, it doesn't make the code any better. I did skip this example really quickly. This is just a really bog standard decorator that I wrote. And this is just to show you that if I run that, you will see when the decoration occurs, and you will see when the decorator's code is running. This example is available in there. You are welcome to, I actually encourage you to fiddle around with it. Add print statements, remove print statements, move things around, experiment with the code to understand the interaction model here. So I told you about the logging decorator. Let me get that out of the way. This is my very simple decorator. It takes a function, and all it does is it logs to a Python standard logger here when it's calling the function, when an error occurred, and when it's returning. Here's where I'm using it. I created this really lovely function called myTestFunction. It takes one parameter, isFail, and if isFail, it fail. If not isFail, it just passes with no problems. And then I'm going to call that function a couple of different times. The first two times it shouldn't fail, the third one it should, right? I'll read that, it's pretty simple. So here is the utility that provides. I didn't have to add to those functions any log calls. Just by adding that one decorator, I get all of this logging for free. It's all built into the decorator. This is super portable for like debugging logging and debugging output. I've got a function that's misbehaving. I don't want to put the log lines in there because I don't want them to live in there maybe for security reasons because I don't want to log too much or something like that. This one line of code is very portable to just stick at the top of my function and get all that logging for free, right? It would be very easy for me to add into this. Do you guys want me to really try a live demo? Let's import time, because we all need more time, right? And up here, I'm gonna, whoop. Oh my goodness, it did that, really?
It's not you.
It's the curse of the live demo. I have angered the live demo gods. Let me disconnect and reconnect, and I've learned that tends to bring things back. Windows has detected that I'm doing things. All right, everybody think good thoughts. I've got it down here, I just don't have it up there. Yeah. Ooh, maybe? We are right with the live demo gods again. All right, so in here, I'm going to do a started at. We're going to initialize it to time.time. That's just going to give us a timestamp of now. And then down here, I'm going to add in, and this is really terrible because I'm going to repeat it twice. Elapsed equals, you guys get to learn how much of a spaz I am when I type. I'm going to add this line, and I'm going to, just for poops and giggles, add it down here. And then I'm going to add my elapsed in here. And likewise, I'm going to add it in here. It's always fun when you type on a new keyboard that you're not used to. Congratulations, I just added performance logging for free. So this is a really useful pattern for trying to grab information, especially for misbehaving objects or for things that maybe you think that it's taking too long, and so you want to stick logging on there, but you don't want it to be there permanently. It's a good, easy thing to move around. So we like the logging decorator? Yep. Logging decorator is kind of fun. Okay, but wait, there's more. It's like a Ronco product. It slices, it dices, it makes julienne fries 3 different ways. Next, we're going to talk about parameterized decorator. Remember that inception joke I made earlier? What's a parameterized decorator? It's a function that takes some parameters, that returns a function, that takes a function, returns another function in its place. We went another level deeper in the dream there. Parameterized decorators are useful when you want to pass parameters into that decorator, either to use or to indicate some really cool and interesting things. I'm going to show you actually 2 examples here, and they're actually written 2 different ways. Hint, one of them's a class. So the first one I'm going to look at is one that we have called the locking decorator. This is a decorator to indicate that this function needs exclusive access to a resource, and we're doing that using a lock. Is everybody here familiar with a lock? You're talking threading, a lock? Process acquires a lock. No one else can acquire that lock until that lock is released. It's a great way to make sure that one thing at a time operates on something. This decorator is really cool because you tell it, it uses the lock, and you pass it the lock object. And then the wrapped function automatically acquires the lock, runs the function, and then releases the lock when it's done, even if it hit an exception, right? This is a really easy portable way to stick @uses lock and give it the lock that it needs to use, and you're off to the races. You don't have to add that with statement in every one of your functions. You just move that decorator to where it needs it. So I promised an example, because I like to bring examples. Here's an example of that locking decorator, right? And tie pins for the win, by the way. I wrote all these in from the beginning. It's like we were seeing before. It's going to acquire the lock. It's going to call the function. It's going to release that lock. And again, we could add performance information. Here's how long it waited for the lock to acquire. Here's how long it held the lock. Here's how long the total elapsed time was. Be easy to add that stuff into here. I'm going to establish 2 locks. Let's say that this is a UI automation library, because I live in Pandy's world too. Let's say that we have a lock for the keyboard and a lock for the mouse. Some things use the keyboard, some things use the mouse, some things use both, and they're special. I'm going to establish a keyboard lock and a mouse lock, and then I'm going to decorate a couple of functions with those. So I'm going to say, hey, when I want to type a message, I want to be the only one that's using the keyboard. Don't let anybody else use the keyboard until I'm done. Same with this send keys. I want to send keystrokes to the keyboard, so make sure I'm the only one that's doing it so we don't step all over each other's toes. Same with mouse. Notice that these 2 functions are tagged to the same lock. This function's tagged to a different lock, right? This is really portable to say, hey, this uses that lock, this uses that lock. I apologize for this code, because in order to demonstrate what a lock does, I have to spawn a bunch of threads, and threads are a little painful to work with. But magic will happen when I hit this button. You see a bunch of things that are all working in parallel right now. So I've started off a bunch of threads. They're all firing off 3 different copies of those functions. Those functions aren't doing anything too interesting. They're just pausing for a few seconds, but enough that you can see that things are working. I like this because it puts the information about exclusive access right there at the top, right where it's easy to see. It's not buried in the code. It's not 4 lines inside. It's right there at the top. And it's really easy to move those around. Is this kind of cool? Yeah? It's kind of cool? All right, all right. So I promised you another example, and this one's even more fun. This is what I call the registration decorator. This is a lock, or this is a decorator, but as a class, right? So we are creating an instance of a class. The instance of the class is the decorator, and the magic that makes that work is this dunder call method. So this is when I call that instance, when I put parentheses after that instance and pass it parameters, it is going to execute on those as if it were a function. So what I'm doing is I've got a category collection object here. It is a variant of a list. So I've subclassed the user list. So I get all of the functionality that you get with a list, right? You get append, you get clear, you get all of the indexing and all of that stuff for free. What I'm doing is when you take the instance of this object and you call it, it is a decorator. It will register a function to this list. And then that allows me to do this method. This is a list of rules. And I want to know which rules the input violates, right? So go over to this fun example here. Here's our category collection we were just looking at. I'm going to do a set of grammar rules in here. So I'm creating my decorator here, this grammar rules decorator. And now I'm going to apply that to each of these different functions to indicate that this is a rule, right? Functions are pretty simple. Starts with a capital letter, ends with punctuation, that the I is capitalized, right? that the word I is capitalized. We don't have I by itself as a lowercase letter, because that'd be terrible grammar. Types of mistakes I make all the time. But here's what's kind of cool. I'm going to run that against a couple of different strings, and I want to know which rules I violate in each of those. Maybe this is input text or something like that. So when I run this, what that violates returns is a list of the names of the functions that returned false, a name of the rules that this violates. So notice when I pass it, I am someone, and I is not capitalized, it violates the starts with a capital letter, and I is capitalized, right? The example of this that we have in our code base is we have stuff that captures network packets. We have a rule that all of our software can't use insecure protocols and must only use secure protocols. So I have a variant of this for all of the secure protocols and a variant of this for all the insecure, and then each of the different filter functions is just tagged to which category it belongs in. And the nice thing about decorators is you can chain decorators. You can stack them on top of each other and apply multiple decorators to a single function. And that's really neat because I can categorize all of these different functions in that, and then I can call one method off of that and determine which rules it violates. Instead of calling each and every function on its own, I can just register them with this and then call them at once with that. Is this pretty cool? All right, we are mercifully close to the end here. I'm almost there. The last one I'm going to talk about is the ones I think is the most dangerous, and that's mutating decorators. That's decorators that either change input, change output, or both. These can be very useful, but they have to be used very carefully. So the example that I have here is what I call the defaulter decorator. Let's say that you're processing payload from a website, right? Like you get a big blob of JSON and you want to be able to extract information out of it, but you want to handle situations where maybe that information isn't present or it's malformed. You don't want to throw up exceptions. You really want to make sure that you get a valid value. So this is a decorator that takes parameters, and this is written in what I call the PyTest style. Josh was telling me earlier that there's another library that makes this pattern a lot easier. But the idea is this is a decorator that can be used with or without the parentheses. You can use with the parentheses to pass parameters, but you have to pass them as keyword arguments. But what this does is I can decorate a function to say, check that the output is this type, convert it to that type, and if it fails to call or if it fails to convert, return to me a default value instead, right? So example here, I give it the function that I want to decorate. I give it the type that I expect it to be. It defaults to string. I give it the exceptions that I expect it to catch. Right now, by default, it catches all exceptions, but you might want to be more specific. And then a default value, which in my case, I give it none. You can see really quickly, it's not doing a lot of really complicated stuff. It's calling the wrapped function, it's getting the return, it's trying to cast the return to the type that you expect, it's catching exceptions in both of those cases and returning a default value. Notice that it is logging, and this is one thing that's very important in a decorator. If you are handling exceptions, make sure that you log exceptions. Otherwise, this becomes really hard to debug. So I can show an example of what this looks like in practice. This is my defaulter decorator. And what I've done is I've decorated a method down here. Let's say it takes a payload, and what it's going to do is it's going to extract the session value that's in there. And I expect that session value to be an integer. And if that session value isn't there or there's any problems, just return 1, right? Like that's my sentinel value for something's gone wrong. And I'm going to call that in a couple of different ways. And you see in here, when I passed it an integer 5, it just returned the integer, right? When I passed it a string 5, it converted it to an integer. So again, I'm always getting an integer as an output. And when I gave it none, it caught that exception and gave me back my default value. And when I got nothing in there, it gave me my default value, right? This is really useful for ensuring that you get certain things. Another way that I've used this type of thing is to check for a default override value. Like maybe we're passing input to this script and we want to make sure that we force a value to a particular thing. Same thing could be done in here really easily. You could check before the call to the function, and if you have a default value, just return that, and otherwise you run the function and get the value from there. This is really useful, like I said, for ensuring you get the same type, for ensuring that you always get a value, that you don't get an exception raised here. Maybe this is running test automation code and you don't want it to just fail out without checking everything out. The screen, again? I cannot win with this screen, and I'm not even touching the laptop for the most part. So let's talk about pros and cons in Decorators. Do you guys have any ideas of what kind of the pros and cons would be? Like, what are some good pros? Just shout one out. Don't repeat yourself. That code's really portable, and you don't have to put that boilerplate and everything. I love that one. That's my favorite reason for using them. Anybody else have another pro?
Saving stuff you don't feel like fixing or maintaining. It's like
Temporary. Right, like temporary code. You want this to be here now, but maybe you don't want it to be in production, or you don't want to keep it there permanently, but you need it, say, for debugging or whatever. Yes. I also think that decorators, when they're well written, can really aid in readability. You know, think back to that uses lock thing. Like, it's really easy to see right there in the function definition, like where you're looking at the signature of that function, right above that, it says, hey, it uses this lock. Like, that's your signal. Think of the categorize decorator. You're signaling that this function belongs to this category of functions. That's really simple to read, easy to see. Some cons, a little decorator can hide a lot of complex code. And so it's one of those, the crumb doesn't look like the whole cookie, but it could be the whole cookie. And that can be a good thing and a bad thing. You can create a layer of indirection, which makes debugging really, really hard. What's being handled by the decorator versus what's being handled by the wrapped function can kind of become a problem if you don't carefully handle like logging and things like that. And then parameterized decorators, like I said, it's a function that takes parameters that returns a function that takes a function that returns a function. That's really complicated to maintain. There's layers in there that you have to really understand what's being used where. So that's all I have. I wanted to just give a quick shout out. My team's with me, actually. They actually helped me review all of this. Every teacher is a student, and they're the ones that teach me every day. So thanks.